Have you ever thought about what happens when the sun, our star, throws a tantrum? Picture this, a quiet, serene day on the sun's surface, when all of a sudden, a colossal explosion of energy disrupts the tranquility. This, my friends, is a phenomenon known as a solar flare. Now let's break it down a bit. What exactly is a solar flare? In simple terms, a solar flare is a sudden, rapid and intense variation in brightness that occurs on the surface of the sun. It's like the sun suddenly decides to put on a light show, but this is no ordinary spectacle. These flares are the sun's way of releasing extra energy, and they pack quite a punch, equivalent to billions of atomic bombs. But where do these flares originate? They're born in active regions around sunspots, areas where the sun's magnetic fields are the strongest. The magnetic energy that is stored in these regions is suddenly released as a solar flare, catapulting radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. This radiation, however, doesn't just stay put. It travels outward into the far reaches of space. And here's where it gets interesting. Though these flares are a magnificent display of the sun's power, they're not just for show. They have significant implications for our solar system, and indeed, our very lives here on Earth. Imagine our solar system as a giant pool, and the sun as someone doing a cannonball dive. The splash, in this case the solar flare, sends ripples across the pool, affecting everything in its path. But what does it mean for us when these ripples, this solar energy, reach our tiny blue planet? What happens when the sun's tantrum, these massive solar flares, interact with our solar system? So, solar flares are essentially the sun's way of releasing excess energy, but what happens when this energy reaches our solar system? Stay tuned as we delve deeper into this fascinating subject in the next scene. When the sun has a temper tantrum, it doesn't go unnoticed in our solar system. Picture this, a burst of energy, equivalent to millions of nuclear bombs erupting from the sun's surface. This, ladies and gentlemen, is a solar flare, and it's as dramatic as it sounds. When our sun decides to put on this pyrotechnic show, the effects ripple out across the solar system. Now let's bring it down to Earth. As the closest planet to the sun, we feel the impact of these solar tantrums quite directly. When a solar flare occurs, a wave of charged particles hurtles towards us at a speed of over 1,000,000 miles an hour. These particles can play havoc with our technology. They can disrupt satellite communications, cause navigation systems to go haywire, and even lead to blackouts in our power grids. But it's not just our gadgets that are affected. Solar flares can also have a tangible impact on our planet's weather. They can cause geomagnetic storms in the Earth's atmosphere, which in turn can lead to increased cloud cover and changes in wind patterns. However, Earth is not the only planet in the solar system that feels the sun's wrath. Other planets and celestial bodies also bear the brunt. For instance, the charged particles from solar flares can strip away the atmosphere of Mars, making it even more inhospitable than it already is. Even as far out as Pluto, the effects of solar flares are felt. They can alter the trajectory of comets and influence the formation of planetary rings. They can also cause the outer planets to radiate more heat than they receive from the sun, affecting their weather and climate. Indeed, the sun's influence is far-reaching. It is the central powerhouse of our solar system, and its moods can send waves of change rippling out to its farthest corners. But the sun's influence doesn't stop at our doorstep. It reaches far beyond Earth, affecting other planets and bodies in our solar system. From Mars to Pluto, no planet is immune to the sun's influence. The sun, in all its blazing glory, is the central force that holds our solar system together. But with great power comes great responsibility, and the sun's influence isn't always benign. One of the most dramatic ways it flexes its cosmic muscles is through solar flares. Imagine the sun as a gigantic nuclear fusion reactor, continuously churning out energy. Occasionally, this energy takes the form of a solar flare, an intense burst of radiation that can catapult billions of tons of charged particles into space at incredible speeds. These solar flare eruptions are some of the most powerful events in our solar system, and their effects can be witnessed far beyond the confines of our star. So, how do these solar flares affect the other members of our solar family? Well, the impact varies depending on the planet. For planets like Mercury, which is closest to the sun, solar flares can have a profound effect. They can strip away the thin atmosphere, leaving the planet vulnerable to the harshness of space. Mars, once believed to have a thicker atmosphere and water, could have been stripped of these vital resources over billions of years due to the relentless bombardment of solar flares. The loss of an atmosphere can dramatically alter a planet's landscape, making it inhospitable and barren. But it's not all doom and gloom. Solar flares can also create some of the most beautiful phenomena in our solar system. For instance, they are responsible for triggering the spectacular auroras on planets like Jupiter and Saturn. These cosmic light shows are a testament to the sun's influence, painting the planet's skies with vibrant strokes of color. So from the rocky surfaces of Mercury and Mars to the gaseous atmospheres of Jupiter and Saturn, solar flares leave their mark in numerous ways. They shape, influence, and transform the environments of our solar system, demonstrating the sun's power and reach. As you can see, the sun's influence is far-reaching. But what does this mean for us here on Earth? Solar flares are more than just cosmic fireworks. They can have serious implications for us on Earth. Solar flares, these spectacular eruptions of energy on the sun's surface, are indeed a sight to behold. But they are not just about alluring visuals. These powerful explosions can have far-reaching effects, some of which can directly impact our lives. Imagine this: a colossal solar flare, many times the size of Earth, hurtles towards us at breakneck speed. While our planet's magnetic field shields us from the worst of it, the resulting geomagnetic storm can wreak havoc on our technology-dependent world. Power grids can falter, satellites can malfunction, and communication systems can get disrupted, plunging us into a sudden, unexpected silence. It's like a cosmic game of Russian roulette, where we don't fully control the odds. But let's not be too gloomy. Solar flares have their brighter side too, quite literally. When charged particles from these flares collide with Earth's magnetic field, they can cause mesmerizing natural light shows known as auroras. These ethereal displays of vibrant greens, purples, and reds dancing across the night sky are a sight to behold. Northern and southern lights, as they are commonly known, are not just a visual treat. They are a testament to the complex interactions between our planet and the sun. They serve as a reminder of how intimately connected we are to the rest of the cosmos, despite the vast distances that separate us. And let's not forget, these solar flares are an integral part of our sun's life cycle. They are a manifestation of the sun's dynamism, its ever-changing nature. They are an indication of the celestial ballet that's continuously unfolding in our universe, a dance of energy and matter that has been going on for billions of years. So, while solar flares can pose a threat, they also remind us of the incredible power and beauty of our universe. So what does the future hold for solar flares and their influence in our solar system? A question that scientists, astronomers, and space enthusiasts alike are working tirelessly to answer. The future of solar flares is a topic of intense research. As we push the boundaries of our knowledge, we're developing new technologies and methodologies to better understand these fantastic solar phenomena. We're not just observing from afar anymore. We're sending spacecrafts closer to the sun than ever before, braving the intense heat and radiation to gather invaluable data. These missions are seeking answers to some of the most pressing questions about solar flares. What triggers them? How can we predict them with greater accuracy? The knowledge we gain could be essential in mitigating their potential dangers. Remember, solar flares can unleash a torrent of high-energy particles that can disrupt our satellites and even our power grids on Earth. Understanding these phenomena better could help us protect our technology, our infrastructure, and even our astronauts in space. But it's not all about the dangers. Solar flares are a natural part of our sun's life cycle. They are spectacular displays of solar energy, creating breathtaking auroras that light up our planet's polar skies. As we learn more about them, we also deepen our understanding of the sun, our solar system, and the wider universe. Moreover, the study of solar flares could have implications beyond our own solar system. By understanding our sun's behavior, we might be able to predict the behavior of other stars, helping us in our search for habitable planets and extraterrestrial life. The future is bright, and it's not just because of the sun. Our thirst for knowledge, our curiosity, and our determination to understand the universe are leading us to new frontiers. And so, we continue this journey of exploration and discovery, not knowing where it will lead us, but excited about the possibilities. As we continue to explore the frontiers of space, Understanding solar flares and their influence in our solar system is just one piece of the cosmic puzzle.